Good afternoon. This is Akanksha Shukla from Information Technology Department. Today I am going to discuss about the topic that is generalization in the neural networks. As I had already discussed about the topic neural networks, so basically the neural networks reflects the behaviors of the human brain, or it comprises the node layers which contains the input layer, one or more hidden layers and one output layer. We can see here this topic is already discussed, but just like I am going to give a review only here. So this is a neural network containing one input layer, one or more hidden layer, multiple hidden layers, and one is output layer. In this, the concept behind the artificial neural network is this: if the output of particular individual node is above that particular specified threshold value, just like if we take an example that a specified threshold value is somehow 2 or 0.2, then if the output of that particular individual node is above that specified threshold value, then only that node will be get activated, or that node will be get fired, and then it will be able to send the data to the next layer of the network. Otherwise, no data will be passed to the next layer of the network. So this is the basic concept behind the neural network, behind the working of the neural network. Okay, the working of neural networks, the types of neural networks, these things are already discussed, and the principal reasons why the neural networks are so much attracted or so much the keen interest in current trend is the existence of the learning algorithms for the neural networks. There are three approaches to learn in the neural network: supervised learning, reinforcement learning, unsupervised learning. These three are already discussed in detail in my previous video lectures. So the main topic of today's, the main concern of today's lecture is the generalization in the neural networks. Basically, the classification and the regression functions which are estimated by using the multi-layer perceptrons or the MLPs are unknown. So what we have to do, we have at the initial level, we have only a training data set. So all we have a training set which can be able to give the input output examples of that particular function. So if the role or the role of the neural network training is to identify that particular function which is in the form of mystery. Okay, because what we have only the training data at present. Okay, so that what the training purpose does, the training process, what the main purpose of the training process is, the training process mainly estimates the parameters of that particular mystery functions, that is the weights of the network, so that it can replicate the data as much as possible. Okay, after that, why it replicates the data as well as possible? Because after the replications of the data as much as possible, it can be able to generalize that particular data in the form of new data. Okay. So it turns out that obtaining the best generalization performance on the new data, it is not usually the same solution as replicating the training data set as well as possible. So what we do, we have to consider the case just like in this, when we have very few training patterns, but a large network with many patterns. So here I am going to consider cases when we have a very few training patterns, but a large network with many patterns. So it will be very relatively easy to manipulate the weights to reproduce the training sets, but it does not seem likely that the resulting network will have learned the characteristics of that particular new data which is generalized by replicating the data. Okay. So on the other hand, what we see, if we have many training patterns and we manage to train the network to replicate them. Okay, here there are two cases. First one is when we have a very few training patterns but a large network with many patterns. On the other hand, on the other hand, we will consider that if we have many training patterns and we have to manage or we have to train that network to replicate them, then it will seem that it is more likely to respond correctly to new or unseen patterns. So what is the aim? What is our aim? Our aim is to make such precise intuitions to develop the approaches which can maximize the generalization performance of a network. Means we have to apply, or we have to develop that particular approaches which can be able to enhance or maximize the generalization performance of a particular network. To evaluate the generalization, we have three sets. First one is training set, validation set, and the third one is evaluation set. So the obvious way, or the simple way to obtain an estimate or to find out the estimations that how well a network can generalize to test its performance on the new data, we have to be careful which type of data we are using or from which source we are taking that data. So if we keep on using the same test set, then although this data is not being used by the training algorithms, the fact we are trying to get the best performance on that particular data set may cause other factors also, just like choice of learning rate, to be tuned to this test set. So to make these distinctions or to make this separation explicit, it is common to work with these three data sets. Okay, so first data set is training set. In this training set, the training set data contains what type of data training set contains? This is normally the data which is used by the training algorithms, and basically the data which we are using to train the algorithms, and the purpose of that particular data is to adjust the weights of the network. So training set contains the data which is used by the training algorithms to adjust the weights of a particular network. Second set of data is validation set. This data is used during the training to assess how well the network is currently performing. Means the performance of the network on this data may be used to guide the training in some way, or it can be able to control the learning rate also, and also it can be able to decide when to stop training, choosing between the several trained networks. So validation set basically assess or basically estimates how well the network is currently performing on the basis of the particular training data set. Okay, so in the validation set, what we identify or what we estimate that how much the performance of the network is evaluating on that particular data, and now how to guide the training or how to control the learning rate, or if the performance is so much high, then we can also be able to stop training that particular data, and we can also choose, if we are having several trained networks, then whatever the networks or whichever trained network is performing in more accurate manner, then we can also choose that particular trained network by using that particular validation set data. The last one is evaluation set, test data set. So this is the genuine test data, and ideally it should be used once only after training is complete. Means after the after the system is trained properly and it is also validated, then when we are going to perform the test over that particular model, then we use the test set data. So this is genuinely data which is going to be tested, and it can be only evaluated whenever the training is complete properly. After training, we can evaluate this type of data, this data set, okay, to check that whether the particular model which is created or which is designed is performing well on that particular genuine test data or not. Now, what is training and generalization? Each training example which are presented to the network, it can be represented by a certain subsets of the total set of functions which are available to that particular network. But if the intersections of the function subsets which are related to that each data point is non-empty, then that particular training set can be learned perfectly by the network. Here, the main thing is that to finding a set of weights that corresponds to such a function is not guaranteed. This is one of the training problem. Okay, one of the training problem is what? That when we have to find the set of weights which corresponds to that particular mystery function which I had discussed at the starting of my lecture is not guaranteed. Okay, so this is one of the main problem which can be faced during the training process. Whenever in the case of MLP learning, a logic function, okay, just like we take an example XOR, in the quantum computing we use the tensor data, okay, or tensor function. So in the case of MLP learning, the logic function just like XOR, then this is the case after training. Okay, so in the case of MLP learning, a logic function is a case which can be used, or the logic function is a function which can be used after the process of training. So in the pattern recognition, it is not usually the case that a network can be able to learn exactly all the training data. Indeed, it is not always desirable to do this. So in the pattern recognition, what we can see that it is not usually the case that means generally the case is not be considered in the pattern recognition that the particular network is able to learn exactly all the training data set. Okay, means the learning of whole training data cannot be always or cannot be usually possible in pattern recognition system. Okay. In short, we can say that generalization is a nothing, it is a measure, it is an estimation which tells how well the network performs on the actual problem after the training process is completed. So it can also be measured by looking the performance of the networks on the evaluation data, just like I had discussed about 3 kinds of data sets. So one out of these 3 data sets, one was evaluation data set. So the generalization can be measured by looking at the performance of the network on the evaluation data which are unseen during the training process. So by the definition of generalization, we can also say that such data is not available when the data is being trained. Okay, so if we want to able to predict the performance of the network over that particular data, and you want to train that network so that it can be able to maximize the predicted performance. So that maximizing the generalization performance of the network involves producing the best possible performance on the new data which is going to be generalized on the basis of the data which are provided you in the training data sets. So simple approach to estimate the generalization performance of the network is to evaluate their performance on a validation set data. If a particular network is performing well over the validation set, then it can also be able to perform well over the test data. So whenever you have to estimate the generalization performance of any particular network, then you have to evaluate, first of all, you have to evaluate their performance on a particular validation set. Okay. Then once the network is trained by minimizing the error function with respect to the training data set, then the performance of that unseen test data can be estimated using the validation set. So if you want to choose between that different networks which are trained on the same data, then we can choose the one that performs best on the validation set. Suppose with respect to the training data set, we have to identify the network which is performing well. So which network we consider? We consider that network which is performing best on the validation set. So we will consider, or we will identify that particular network which is performing best on the validation set apart from the multiple networks which are given here. So this procedure is sometimes called a holdout method. Okay. Since the validation set may be regarded as a data held out from the training set. So the method, holdout method, is nothing. It is a method through which we can choose the different networks which are trained on the same data. Okay. Then what we have to do? We have to choose from that particular networks to that network which is performing best on the validation set. So this procedure, or this whole procedure is known as the holdout method. Now I am going to discuss about one more topic, just like the competitive learning in the ANN. ANN is artificial neural network. So what is the competitive learning in artificial neural networks? Basically, the competitive learning is concerned with the unsupervised training in which the output nodes tries to compete with each other to represent the input pattern. But to understand this learning rule, we have to understand the competitive net first of all. So the basic concept of competitive network is that it is just like a single layer feed forward network which is having the feedback connections between the outputs. Okay, here the connections between the outputs are in bitray type, which is shown by dotted lines, which means the competitors never support themselves. Means here what we see, that there is a network which is a kind of single layer feed forward network. Here we can see the feedback connections between the outputs, but the connection between the outputs are inhibitory type, means they are shown by the dotted line, and also it means that the competitors or the different outputs are not supporting each other. Okay, we can see in the given example that there is an input, multiple inputs are given, and here the outputs are given, and but these outputs are connected through a dotted line, means the outputs are not supporting each other. Now, what is the basic concept of competitive learning rule? As I said earlier that there would be a competition among the output nodes. So, the main concept here is the during training what we have to do, the output unit that has the highest activation to a given input pattern will be declared the winner. Okay, just like in the artificial neural network I had told that whenever an individual node, whenever the output of any individual node is above the specified threshold value, then only that particular node get fires or get activated and can be able to pass the data to the next layer. Same here, that in the competitive learning network, the competition among the output nodes are visible, or there would be a competition among the output nodes. So, what we do, we declare the winner during the training period only, and on which basis we declare the winner, that the output unit which has the highest activation for a particular given input pattern, which individual node is having the highest activation corresponding to a particular given input pattern, will be declared as the winner of that particular learning concept. Okay. So, this rule is also known as the winner takes all, because only the winning neuron is updated and the rest of the neurons are left unchanged. Okay. Just like in this given example, these nodes are considered as an individual nodes, or these are considered as the neurons. So, apart from these outputs, whichever node is having the highest activation corresponded to a particular input pattern, then that individual node will only be updated. Rest of the neurons are left unchanged. Now, the mathematical formula here is, the three important factors for the mathematical formulation of this learning rule is, first of all, what is the condition to declare the winner? So, suppose if a neuron yk wants to be a winner, then there would be a following condition, that yk is equal to 1 if vk is greater than vj for all the value of j, and here j is not equal to k. Okay, and if a neuron is having, otherwise the value of neuron will be declared 0. So, if any neuron, say yk, wants to win, then its induced local field, the output of the summation unit, then it should induce the local fields of the outputs of the summation unit. Okay. Yk must be the largest among all the other neurons in the network, means if you have to declare a particular neuron to be a winner, then it must be the largest among all the other neurons which are present or which are located in that particular network. Second, condition of the sum total of weight. So, another constraint over the competitive learning rule is the sum total of the weights to a particular output neuron is going to be 1. If we consider here the neuron k, then sigma k wkj is equal to 1 for all k, means the second condition for following are the three important factors for mathematical formulation of this learning rule is, first is the condition to be a winner, the second is the condition of the sum total of weight. So, for that condition, what we consider that the sigma wkj is equal to 1 for all the values of k. Here k is a neuron. Okay, here we are considering the neuron is k. So, in this rule, the constraint is that the sum total of the weights to a particular output neuron is always be 1. Next is change of weight for the winner. If a neuron does not correspond to the input pattern, if a particular node or neuron is not corresponding to a particular input pattern, then no learning take place in that particular neuron. So, if a particular neuron wins, then the corresponding weights are adjusted as follows. Means, if a neuron does not responding to that particular input pattern, what I said earlier, that the winner or the neuron will be declared as a winner when only the activation function will be the highest for that particular neuron. and that activation function corresponds to the input pattern. But if the neuron does not respond to the input pattern, so no learning rules take place in that particular neuron. But although if a particular neuron wins, then the corresponding weights are adjusted as following rules. Okay. On the basis of this rules, here alpha is the learning rate. So on the basis of this learning rate, what we do, we adjust the weights if a particular or if any individual neuron wins apart from corresponding to the input pattern. So these three are the mathematical formulations for the competitive learning rules. First one is condition. What are the conditions to be a winner? The second one is the condition for the sum total of the weights, and the third one is change of weight for the winner. So as I had seen that we are favoring the winning neuron by adjusting its weights, and if a neuron is lost, then we need not bother to readjust its weight. Okay. So the condition of adjusting the weights occurs only when the neuron is to favor the winning neuron only. Okay. But when if a neuron is lost, then we need not to bother to readjust their weights. So in short, we can say that, or to conclude this topic, we can say that this is a form of unsupervised learning in the ANN or SNN, in which output nodes compete to each other in respect to a subset of the input data, whatever the input units are provided to that particular network. So a variant of Hebbian learning or competitive learning works by increasing the specialization of each node in the network. Okay. This is a competitive learning. It is a variant of Hebbian learning. It works by increasing the specialization of each node in the network, and it is well suited to find the clusters within the data. I had already discussed about the topic clusters. What are the clusters? Clusters contains the data which are exhibiting the similar characteristics, just like if you are taking this kind of data. So what we see here, these 4 images are similar. So we form a cluster 1 here. These 2 images are similar. So we form a cluster 2 here. Means cluster simply exhibits or implies the data or the images or any input things which can contain the similar characteristics within it. So that's all for today. Thank you.